This lesson is over Unit 7. We're going over 7.6 and 7.7, finding solutions to differential equations. So basically, a differential equation is where you're given the derivative of the function. Like these examples down here, notice how we have dy dx, which means derivative is equal to 2 times x times y. That is a differential equation. This is a differential equation. It is dh dt. Gives you the function for dh dt. And it could even say y prime. But wherever you're given a derivative and you have your variables, that is a differential equations. Now, here are at least the 7 things that they could ask. We kind of went over sketching slope fields, or like doing slope fields. Today we're going to focus on just finding the general solution to the differential equation. Right? They could also ask you to find the second derivative, to determine relative extrema, anything about tangent lines, or write an equation of the tangent line. So that's kind of everything that they ask you. So today we're going to be given a differential equation, and then we're going to write the equation for it. This means that given dy dx equals, we need to find the equation y equals f of x. Usually this requires some form of integration, but we have to work with our derivatives on both sides. And in this course, you're going to learn about separable differential equations. If you take courses later on, you'll have non-separable differential equations. But what that means, when you say separable, it means that you can separate dy and dx through multiplication. For example, here, on example 1, it does say separate the variables. So again, we can get rid of this dx on bottom, right, by multiplying it. So we multiply dx to each side. Those dx's cancel. And then notice over here how we have x and y on the right side with dx. So we actually want to move this y plus 3 over. And you do that by dividing by y plus 3 on each side. And then my final answer is going to be 1 over y plus 3, dy, equals 2x dx. So notice that all my y's are on the left, all my x's are on the right, and that is what we mean when we say separate the variables. So separate the variables, and then put the associated dy and dx on that side. So whenever you're working with a differential equation, you always want to multiply both sides by dx. Then you have to separate the x and the y, or whatever variables there are, by multiplying and dividing. After that, you need to integrate both sides after you've isolated the variables. Sometimes you do have to do u substitution. And then whenever you do integration, you always have the plus c. Here we'll be solving for the c by using the initial condition. And then finally, you got to get y by itself. Okay, so example 2, we are given our initial condition of 1, 4. So we're going to use that when we solve for c. But our first step is to multiply by dx on both sides. So doing that, we're going to get dy is equal to x plus 1 over y times dx. And then we're going to isolate. Our next step is to get the y's to the side with the dy and leave all the x's with the dx. So if I want to get this y over, I do multiply it to the other side. Okay, so there you go. There is step 2 done. Now we do need to integrate both sides. Okay, so if I integrate y, again, we're just going to add 1 to the exponent, so that becomes y squared, and then divide by 2. And then if we integrate the x side, again, this is x to the first, so add 1, so that's going to be x squared, and then divide by 2. And then also you have to integrate 1, and that will just be 1 with the x. And then we need to add a plus c. Now it doesn't matter if we just need 1 plus c. We don't need to add c to both sides. Because if you think about it, if I add c1 here and then c2 here, I could always move this constant over. It combines and it's still just a constant. Because again, this represents any constant. So we'll just put the c over there with the x. Now our next point is we need to find c. And we're going to do that by substituting in x equals 1 and y equals negative 4. Because that's our initial condition. So you plug that in there, there, and there, and then solve for c. So here you're going to get 16 divided by 2, which is 8, equals 1/2, plus 1 plus c. And then if I get c by itself, subtract 1/2, and then subtract 1, so that's going to give me 6.5 is what c equals. And if I converted that into a fraction, that would be 13 over 2. So now that we have c, our last step is to finish by isolating y. So we have y squared over 2 equals x squared over 2 plus x plus 6.5. Now, I'm going to multiply 2 to everything. That's going to give me y squared equals x squared plus 2x plus 13. And then I'm going to square root. And we do get plus and minus. But we know from our initial condition, because again, if you look, our initial condition was 1, negative 4. So our y value is going to be negative at 1. So if you plug in 1 here, right, that's 1 plus 2 plus 13. So that's 16. So the square root of 16 is 4, but we're using negative 4. And again, it's because of this initial condition. So we're using the negative portion of it. And there you go. So that is the solution, or that is the equation that gives all the solutions to this differential equation. Okay, moving on to example 3. So again, we're going to consider the differential equation dy dx equals 2xy. Find the particular solution given that we have an initial condition of 2, 1. So again, my first step is to isolate dy and dx. So let's multiply dx to each side. If I multiply dx to the left side, those cancel. And so we'll just have dx over there on the right. And then get all your variables to the side with their partial derivatives. So we're going to divide by y. Okay, so we have isolated. It is time to integrate the left and the right side. Now, we know that the integral of 1 over y is log of y. And then if we integrate the x, we're going to add 1. So that becomes x squared, and then divide by 2. And those cancel out, and we're going to always add our plus c. Again, you could add the plus c to the left side, but we're just going to add it always with the x. Our next step is to solve for c. So we're going to plug in 2 and 1 for x and y. So log of 1 is 0 equals 4 plus c. So we know that our c is equal to -4. Okay, now we need to sub everything back in. And we need to solve for y. So again, this is a log form. So if you remember, log base b of n equals r, I guess. So if you're trying to switch this from a log to an exponent, you start with the base, go to r as the exponent, equals whatever is here in the index. So let's rewrite this. So this is log base e. So this is going to be e to the x squared minus 4 equals y. And there we go. There is my equation for the solutions to that differential equation. It's the equation that gives every solution to this differential equation. All right, so example 4 is going to be a little bit harder because we're going to have to do some u substitution. But again, we're given our initial conditions of 0, 1. So first thing, multiply dx to each side. And I rewrote this square root as a 1/2 exponent. Next step is to divide by the square root of 7 minus 2y on each side. Okay, now we do have our variables isolated on the left and right. We do need to integrate, and I'm going to rewrite this as a negative 1/2 exponent. And we're going to have to use a double u substitution. So I'm going to call one of them u and one of them v. So we're going to let u equal 7 minus 2y. That means du is going to be minus 2 du. Sorry, dy. And then so we're going to get du over -2 is dy. And then over here on the right, we're going to let v equal 2x. dv is 2 dx. So dv divided by 2 is dx. So this will be the integral of u to the -1/2. This would be du over -2 equals the cosine of v. And this is going to be dv over 2. Okay, so now to integrate, we're going to add 1 to this, and that's going to be positive 1/2 and then divide by 1/2. And then if we integrate, the integral of cosine is going to be sine. Now we do need to substitute back all of our u's and our v's. And I'm going to pull this out side. Again, this is going to reciprocate, so this will be 2 over 1 when it comes outside. Okay, again, so u was 7 minus 2y to the 1/2. This comes out. This is 2 over 1. And always, remember the plus c with the sign. So there is my integration. Next, we need to solve for c. Now here we're going to cancel, so this is just going to be negative. 7 minus 2 times negative 1 to the 1/2 equals 1/2 sine of 2 times 0 plus c. So sine of 0 is 0, so this is going to cancel out. And then inside over here, this is going to be negative 2 times negative 1, which is plus 2. And then again, so that's plus 7, so that's 9. The square root of 9 is 3, but we do have our negative outside. So our c is going to be equal to negative 3. Now I'm kind of running out of room because this problem is kind of long. But let's kind of sub back. So again, we still have our negative outside here. So we have negative 7 minus 2y to the 1/2 power equals 1/2 sine of 2x minus 3. So getting y by itself, so the first thing I'm going to do is move the negative over. Basically, if I divide by negative 1, this turns into negative, this turns into a positive. And I'm just going to turn this back into a square root to show you. And then now we're going to square each side. And then to finish this, subtract 7 and then divide by negative 2. And that is my final answer. Again, because when I subtract 7 from here and then divide by negative 2, so if I divide this by negative 2, that's the negative 1/2. And then it's going to be minus 7 divided by negative 2, which is technically positive. So that's plus 7/2. So that's kind of a harder question. Yes, very long. But that's one of the harder differential equations you'd come across. So as you can see, here is a question off the AP test. So it's asking you to find the slope field, find the solution, and find the limit. So we kind of have a lot of stuff to do. Now, with these points, again, you just take these points and sub them into this equation to find the slope and then kind of draw it. I'll show you a couple by hand. So if you're thinking of 2 comma negative 2, actually, maybe it's easier to draw a table. So 2 comma negative 2, I'm sorry, 2 and 2. So if I plug in a 2 here, I'm going to get 1. 2 minus 1 is 1 over 4. So the slope is 1/4. So if you picture it, 1/4 is going to be something like that. You can kind of use this. Up 1 over 4 would be there. So it's kind of a line that is that steep. Okay, let's plug in 2 comma 1. Again, if I plug in 2 for x, I'm going to get 1/4. And then 1 minus 1 is 0. So this is just going to be 0. And if I plug in this bottom right point, that is 2 comma 0. So again, this will be 0 minus 1, which is negative 1 over 4. So it's going to be the negative version of the one we did on top. Now, without doing all of these, now, when I plug in 1 on top, it's always going to be 0 over a number. So all of these slopes at y equals 1 are going to be 0. So it kind of makes it easy. Because again, no matter what x is, as long as it's not 0. So all of these points right? 1 minus 1 is going to give you 0 over a number, which is 0. Just, you can't have x equals 0. That's why there's no points there. Now, if I plug in 2, 1, comma 2, that's going to give me a slope of 2. If I plug in 1, comma 0, that's going to give me a slope of negative 1. If I plug in negative 1, 0, again, that's 1 on bottom and negative 1 on top, so that's a slope of negative 1. And then if I plug in negative 1, 2, that's going to give me 1 on bottom, 1 on top, so that's positive 1. And there you go. There's my slope field for those indicated points. So part B, find the particular solution. So since we did a bunch of these, I'm going to kind of do a couple steps together. So we're going to multiply dx over here and then divide by y minus 1. Next thing is to integrate. So here we're going to do a u substitution. So notice that we let this equal u. Du is just equal to dy, so there's a straight substitution there. This is going to be log of u, but u is going to be y minus 1. Over here, if you add 1, that becomes negative 1, and then divide by negative 1. And then always add your plus c. Now, our initial condition is 2, comma 0, so we're going to solve for c by using 2, comma 0. So this will be log of 0 minus 1 equals negative 1 over 2 plus c. Now, this is an important reason why these are in absolute values every time you take an integral. So this does have a solution. This is equal to log of 1 because it's the absolute value. And that we know is equal to 0. So we know that our c is 1/2. So solving, let's substitute everything back in. So again, we know that this is e, base e, so it's going to be base e to the exponent of this equals y minus 1. So here is my final equation. Now, part C says we need to take the limit as this approaches infinity. Now, with this constant, we could just pull it out, and all we need to do is plug infinity in here. But we can rewrite this equation, and let me show you how. So we'll pull the 1 out. We'll still take the limit as x goes to infinity. Now, we're going to separate these exponents by doing e to the negative 1/2 times e to the 1/2. And again, the reason is if you have bases that are the same, you can add exponents. It's one of your exponent rules. And it makes it easier because now we can pull out this constant outside. So taking this limit, we're going to just plug in infinity into here. So this will be 1 over e to the 1 over infinity. And again, it's negative, so it does go to the bottom of the fraction. Now, this part equals 0. 1 over infinity is 0. And then e to the 0 is equal to 1. So this whole equation just equals 1. So you're going to get 1 plus e to the 1/2 times 1. But we don't need to write that. And so there is our limit.